Yeah. Yeah, I was telling Sophia I saw her at Chick-fil-A yesterday working and she was outside and I almost like yelled out my car window because we were not getting Chick-fil-A, we were getting Chipotle. And I was gonna be like, "Hey, Sophia," but then she was taking somebody's order. I got Chipotle, sorry. What's that? But I can verify that Sophia was there working. I was spying on her, right? Yeah. All right. Well, I think we lost Olivia again. Yeah. So first, I guess my first question is, does anybody have any questions they want to go over from chapter 7 before we get started on chapter 8? Yep, I know. So the shortcut is to make this little chart. So you say percent and actual. Actual. And we've got our original. We've got our change. And we have our new. So change, we don't actually use when we're calculating. It just kind of helps us to fill in original and new. So these are the two that are really important to get filled in. So for example, if I had something that was, the new price was $20 and that was after it was 15% off. Okay. So my new actual price is $20. Okay. I want to know what the original price is. So that's going to be my X. So then when I deal with percentages, the original percent is always going to be 100. Okay. If something's 15% off, that means it's going to go down 15%. So that means my new percent is 85. So once I have these two filled in, then I can just say X over 100 equals 20 over 85. And I can solve from there. Yep. So this one, you just go like this, right? Yep. So then, like Sophia, if I had, why is this eraser so small? That'll work. Just make boxes of everything. There we go. So Sophia, if I had, let's see. I don't know. I don't have a good example. My brain's not working. Let's say something cost $50, right? But that was the new price. The new price is $50. But it increased 20%. Like it went up in price because whatever it was so popular. Okay. So what I would do is I would say the new actual price, oh, I accidentally left a box there, is $50, right? And I want to find out what the original price is. Now my percents, what's my original percent? What is that always going to be? Always going to be 100. Yep. Okay, so if this went up 20%, my change is going to be plus 20, right? So what's my new percent going to be? Yep. So now I have these two boxes filled in again, and I just do the same thing. X over 100 equals 50 over 120. All right, so it always works. It always works no matter kind of what combination you have. Or, if they give you the original price, if they said the original price was $75, then this could be your X. And you would just write, an equation. It would be 75 over 100 equals X over 120. Cool? Awesome. So hopefully that helps. Just try your best on those. I know every once in a while there's just that one thing that doesn't click in your brain. So I understand that too. Not your brain, but just anyone's brain. I have those too. Mine just happens to be probability that every time I'm like, okay. Okay, so today what I wanted to do is kind of go over a little bit of 8.1 and 8.2. I know we kind of jumbled them together on Monday, and so I want to do a little bit more than that. I didn't see Olivia hop back on. She must be having technical issues. Okay, so if you remember, we kind of started chapter 8, and chapter 8 is graphing, right? And so we talked about a couple of different ideas, but I want to review them all again because they're actually really important. And I am going to clear that off. There's Olivia. Hey, Olivia, can you hear us? Oh, no. I broke Team Viewer. Are you guys still there? Oh, I broke Team Viewer. Are you guys still there? It crashed on me. No, Olivia's here. Yes. Sophie, are you still here? Okay. All right. Yay. You guys are all still here. All right. I'm clicking around somewhere trying to find something. I was trying to find a coordinate plane. So we'll just go ahead and use the graphing calculator coordinate plane. Okay, so what do I mean by coordinate plane? What I mean is this lovely x and y axis, I should draw in there the right way, that we are going to be spending a lot of time on the next few weeks in chapter 8. And actually in Algebra 2, Algebra 2 is a ton of graphing. So we want to make sure that we get the foundation really, really well laid. And you might have done this in pre-algebra or other math that you've done before, but just in case, I just want to make sure everybody's kind of on the same page. Okay, so this is called the coordinate plane. The horizontal axis is always going to be your x-axis. So that's always x, and the vertical is always y, no matter what. Okay. And then we have these different quadrants, but I don't think that's super important to know. But we do want to know how to graph things on the coordinate plane. So when you want to graph a coordinate, what you're going to get is something that looks like this. So if I asked you to graph a point at 2, 3, this is a coordinate point, if it'll let me write 3. 2, 3. So if I just said graph 2, you wouldn't be able to do that. But if I tell you to graph a point at 2, 3, you should be able to do that. So one thing to note is when you get a coordinate like this, that it's always written as x first, y second. Okay, so you don't ever have to think, oh, did they mean which one goes first for this one? It's always x and y. So if there's a way in your mind that you can remember your coordinates are x and y, and your coordinate plane is x and y, then if you can remember those two pieces of information, you should be able to graph anything. Okay, so what I mean by that is if I want to graph 2, 3, that means that I need to go 2 units on my x-axis. Okay, so what I mean by that is this represents 2 units on my x-axis. So this isn't completely labeled, but you can see right here that this is where x equals 2, right? Right about here, okay? And then my y coordinate is 3. So that means that I have, if I just look at the y, see if it'll let me draw. My y coordinate of 3 is right here. Okay, so when I put those together, x equals 2, y equals 3. This point, it doesn't like me drawing points, it thinks I'm like doing something. This point right here is 2, 3. Have you guys done this before? Graph points. Okay, so I'm not like, it's okay to go over it again. You guys aren't like, oh, I've done this a million times. So this is 2, 3. Okay, so what if I wanted you to graph point, let's see, -3, +4. Okay, so this represents x and y once again, right? Always x, always y. So what this means is that my x component is -3. And you don't have to draw these lines on here. I'm kind of exaggerating, right? So my x is at -3, which is right here. You always start at 0, right? And you're going to -3. Okay. And my y is at +4. So +4 is up this way, right? So this coordinate, -3, 4, would be right, no, not what I wanted to do, right here. So this is -3, 4. I realized that I did not do something, I didn't explain something very well. And that is kind of the positives and negatives of the coordinate plane. Okay, so right here in the middle of our coordinate plane, right where my little X thing is, right? My cursor, that's 0, 0. We call that the origin. That's the center of our coordinate plane. And you're always going to have the origin. Like when you go to graph something, you always write this, you know, X and Y, and you've got that point right in the center. Okay. This is kind of like a number line, but we have a number line that's going 2 ways. So if you remember doing number lines a long time ago, if you ever had to do that with your math, anything that is to the right of 0 this way is positive, right? You're getting bigger and bigger numbers. So this is positive. So if I, like I said before, I kind of skipped ahead, but I had a +2. So I wanted to move my number positively along the x-axis, right? And not a huge surprise, if I start at 0 and I move to the left, just like a number line, then I'm moving negative. So that's when I have this -3. Instead of moving my point 3 points to the right, I moved toward the negative axis towards -3. Now, it kind of makes sense because they've labeled it on here, right? Sorry, I just muted for a minute. Is that a cough? Okay. They have it labeled on here, but that's kind of something you should intrinsically know too, that when you move to the right, you're going to get, you're moving toward positive, and when you move to the left, you're moving toward negative. Excuse me. I keep kind of scrolling around and I'm losing my place. All right, so let's clear this off. So then the same thing works for your vertical axis, right? So this is your horizontal, your x-axis. Your vertical axis is your y. You're at 0, 0 again, and it's kind of like they flipped the number line vertically, right? So 0, 0, anything that's a positive y is going to go up. And I think this actually makes more sense, right? Going up, up, up the number line. And when it's negative, you're moving down the number line. Okay. So if I asked you to graph something that was like -2, -2, you should be able to, without, I mean, you can probably look on here and see where that's at, but you should know that I'm going to move -2x, right? And -2y. And I'm going to end up somewhere in this part of my graph, in this quadrant of the graph. And this is actually where -2, -2 would be. Does that kind of make sense? I know what I can do. This is what I should have done. Easy? That's good. We can take an easy section, right? So let me give you, oh, one of the things I need to do at the end of this call is to send out, I have like a paper that you can just print out a bunch of coordinate planes. Okay, so that's one thing. One of the things that you're going to do is you're going to have to plot a bunch of points. So if you, I'm going to write like 4 points. I'll write 4 or 5 down here. I want you to kind of make a quick sketch and try to plot them, and then I'll plot them just to make sure that you get them in the right spot. Okay, so I'm going to give you a few. Okay, so I'm going to give you about 2 minutes to see if you can plot these really quickly. And like I said, if you just have some scratch paper, just kind of plot them on there. And I'm going to get a quick drink of water. So I'll be right back. Okay, I'm back. Does anybody have them all plotted yet? Yep. All right, so let's see. The first one we have is, I should have color coded these. The first one we have is 3, -5. Okay, so we have a +3. This is our, remember, our X and our Y. And starting off, you might always want to label those X and Y. It's not a bad thing till it kind of just sticks in your brain. So this means that we have +3x. So I start at 0 and I'm going to 3, which is right about here. And I have -5, and I made a bad example because my -5 goes off the screen. So that's going to be down here somewhere at -5, because I go +3, and then -5 is going to be way down here on my y-axis. So sorry for that bad example. Okay. The second one is 2.5 and 1. So you can sometimes get a number that's not a whole number. Now, generally, you're going to have a whole number, but once you get into higher level math, you won't. So 2.5, we go 2.5 is a point right here. So it's +2.5 and +1. So we go up +1. So that's where the second point would be, right here. Okay. The third point is at 0, -3. Okay. So we'll write this one in purple. So the X part is 0. And this can confuse people sometimes. But basically, when X is 0, that means that you start here at the middle and you don't go anywhere, right? And Y is -3. So all we have to worry about is going down to a point where Y is -3. 0, -3. And then we have our last point, which is 2, 0. So this one's a little bit different. Apparently, I really like the number 2 today. So this means that our X is +2, right? 1, 2. That our Y is 0. So our Y isn't going anywhere. So this point would be at 2, 0. So were you guys able to get all those? Awesome. Yeah. So that's why I'm saying I will send out some graph paper, or not, it's not really graph paper. It's more like, I don't know, coordinate planes, so that you can do that. Okay, so that's part A. And actually, if you have your notes, if you happen to have your notes with you, I'm going to flip to this page. Actually, I have my notes down here too. I'll pull them up here. There we go. Leave this there and we'll flip to our notes. So we're kind of in 8-2 right now. What we did is I have some plots or points plotted for you right here. So I probably should have just done this. So this is a very simple coordinate plane, obviously, that I just drew by hand, right? We should be able to plot T, V, and Z pretty easily. Okay, so T would be at 0, -4. So it would be, if you want to try these on your own, be at 0, -4. So here would be T. V is at, nope, I totally just did that wrong. You guys like, Mrs. Ross, what are you doing? T is 0, -4. 0x, -4y. I apologize. This is where T would be. So even I can get confused by the zeros sometimes, as you can see. V is at -4, 2. So that would be at -1, -2, -3, -4, and +2. Okay. And z is at 4, -2. So 1, 2, 3, 4, and then -2. Kind of looks like a 2, but that's a z. Okay, so now the second part of 8.2 is graph these equations. So all of a sudden it's like, whoa, where did that come from? What are we talking about, right? So I think I know we talked about on Monday, was that we are entering a new era of algebra where we don't just have one variable, we have two variables, right? We have x and we have y are generally the two variables that we're going to deal with in this section. So if I wanted to graph x plus y equals 0, and I'm going to do it by hand, what you need to do is you need to find a few points that work for this equation and to graph them. Okay, so what do I mean by that? What I mean is that we're going to use a chart to help us out. Okay? And the way I like to do this is I like to solve for y. So if I wanted to solve this for y, what would I do? If I have x plus y equals 0, okay, I can subtract x from both sides, and I get y equals -x. Are you guys okay that this equation and this equation are the same? Yeah? Okay. So my little chart that I'm going to make is not going to be fancy. I'm going to have some x, then I'm going to have my equation, y equals -x, and then I'm going to have my points. Okay? So what happens if x equals 0? And you can pick whatever number you want, but I would pick 0 when x equals 0 first because usually that's the easiest one. So if x equals 0, then I'm basically plugging in whatever x I pick into x over here. So y equals -0, and that's not really, we don't say -0. So that means y equals 0. So one of my possible answers to this is 0, 0. And that makes sense, right? Look at my original equation. Does 0 plus 0 equal 0? That works. All right, so let's pick another one. What happens if x equals 1? Well, if x equals 1, y equals -x, so -1. So one of my other points is 1, 2. Okay. You guys following along so far? Kind of? Okay. We'll do a couple of them so you can get it. I'm running out of room. Let's do one more point. What do you want to make x equal? You want to make x equal a negative number? Let's try that. What happens if x equals -2? Y equals -2. So that means that my point is at -2, 2. So basically what I'm doing, I'm picking an x, and you can kind of pick whatever you want to pick. Usually I would pick 0, at least for one of them. Okay, I'm picking an x, I'm plugging it into my equation, and I'm figuring out, okay, when x equals 0, what does y equal? When x equals 1, what does y equal? When x equals -2, what does y equal? And so now I actually have 3 different points that I know are true for this equation. Okay? Sorry if you hear me muting. I'm keep coughing. So what do these points let me do? They actually let me graph this equation. And I wish I had drawn this up here a little closer. So one of my points is at 0, 0. Oh, look at that. It'll let me scroll up. So if I plot 0, 0, that's right here, right? Right in the middle. I also know that one of my points is at 1, -1. So x equals 1, y equals -1. Okay. Another one of my points is x equals -2, y equals 2. So -2, +2. Okay. So we could do one more if we really wanted to. But do you notice anything about these 3 points? They're kind of lining up, right? Would you agree that they're kind of making a line? Yep. So what if I did, let's just check. Let's do x equals 4. And I know I'm doing this on the wrong part of the graph. If x equals 4, y equals -4. So one of my points is at 4, -4. Okay. 4, -4 is 1, 2, 3, 4. And then -4 is 1, 2, 3, 4. It's down here. So now I have 4 points, and these are definitely making a line. And I don't think I have a nice line tool on here, unfortunately. So now you actually get to play connect the dots and connect your dots. Okay. And so what this is you have actually graphed x plus y equals 0. So what does that mean? That means that anywhere along this line is an answer to x plus y equals 0. So if I said, oh, well, what happens when x equals 3? 1, 2, 3. When x equals 3, I wanted a different color here. When x equals 3, if I drew my graph right, that's where y equals -3. So when x equals 3, y equals -3. And that makes sense, right? If I plug this into my equation, x equals 3 and y equals -3, 3 plus -3 equals 0. So that's another answer, right? If I go way up here, 2, 3, 4. So if I go up here, when x equals -4, y equals, it's not exactly to scale, but when x equals -4, y equals +4. And that's another answer, right? X equals -4 plus +4, that's 0. So what this line represents is every answer to x plus y equals 0. Okay, I'll let that sink in for a minute. What do you guys think of that? Uh-huh. Let me look at your homework. Well, 1 through 12 all is just plotting the points. I don't have my book in front of me. I have 13 through 35, but I hope that they're not all that. Wow. Yeah, no, I do. I'm just saying I don't know if it's that. I'll have to get my my book out because I don't have my book in front of me. All right, so let's do another one. In a long time because I'm explaining every single part. Okay, I'm going to clear this off. It's going away. All right, we have graph 2x plus y equals 10. Okay, so what I like to do, because I think it's easier to solve, you don't have to do this, but I think it's way easier, is I like to solve for y. That's the first thing I always want to do. So what I mean by that is I'm just going to send my 2x to the other side by subtracting both sides by 2x. Okay, so I can rewrite this as y equals 10 minus 2x. You guys okay? This equation is the same as this equation. They're just rewritten different ways, right? So now I make a chart. Okay, what is the x I always like to pick first because it's the easiest? 0. Okay, because what I mean by that is then I say, okay, y equals 10 times minus 2 times 0. What's 2 times 0? 0, right? Yeah. So when x equals 10, or when x equals 0, y equals 10. So my point would be at 0, 10. Okay. Now somebody else pick a x. What x do you want to do? Don't pick like a million. Pick a number between 1 and 10. Anybody care? 5. There we go. So we'll say when x equals 5, right? When x equals 5, y equals 10 minus 2 times 5, right? What's 2 times 5? It's 10 minus 10. And what's 10 minus 10? 0. So another point is at 5, 0. Now here's the deal. In order to graph something, a line, you actually only need 2 points. So technically you could be done and you could graph it just off of 2 points. Because think about it. If you have a point here and a point here and you play connect the dots, you have a line, right? But I highly, highly, highly recommend doing 3 points, because if you do 3 points and your 3 points look like this, like you have a point here and here and here, then you're like, one of these is wrong. But if you do 3 points and they are all in a row, right? We've got 1, 2, 3 points and they're in a row, then you know, I graphed my line. I'm good. So let's do one more for good luck. I say always do 3 points. You're already this far, right? So what other x do we want to pick? We could also pick a negative x too. You're allowed to do that. Excuse me. Or you could stick with the positive ones. It doesn't matter to me. I'm going to do x. I'll do x. How about let's do x equals -1. Make it a little complicated, but not that complicated. X equals -1. So that means y equals 10 minus 2 times -1. So it's basically -2 times -1, right? So -2 times -1 is +2, so that means that y equals 12. So another point is at -1, 12. So now we have 3 points, right? Yes, awesome. I like the confidence. So now what are we going to do? We're going to graph it, and I'm going to kind of cheat here, and I'm going to Aw. Sorry. That'll come back here. My graph paper here. I kind of cheated in getting my graph paper, right? And let me turn my whiteboard back on. Okay, so I have these points, right? And I need to graph them. Where is 0, 10 at? I'm gonna have to kind of turn this on and off. So my first point I want to graph is 0, 10. Okay, so that means that see, I don't have a big enough graph still. Let's scroll out. Okay, so let me kind of start back here. This is the chart that we just made based off of our equation, right? I know that one of the possible answers to this is when x equals 0, y equals 10. So I'm going to graph that on my graph. Okay, so when x equals 0, y equals negative 10. So that would be x equals 0, y equals negative 10. So this would be my point down here. Is that what I said it was, or is it positive 10? No, positive 10. I'm really confusing you guys today. I'm sorry. When x equals 0, y equals positive 10. So that's up here. That's what I was totally trying to do. So this point is x equals 0, y equals positive 10. Okay. The next point that we found was that when x equals 5, y equals 0. So when x equals 5, y equals 0. So that point's right here. X equals 5, y equals 0. And then the next point that we found was when x equals negative 1, y equals positive 12. So that point is when x equals negative 1, y equals positive 12, which is a little bit up here off the graph. It's up here. Okay. So if I actually have my graph go all the way up to where I need it to be, you would see that all these points are in a line. And so then I get to basically connect the dots. Okay, so I can say that my line goes through these 2 points. Okay, so this would be my graph of the line. And then anywhere along this line is an answer to my original equation, which my original equation was 2x plus y equals 10. So if I did this right, like let's take right here, this point right here, okay? This is when x equals about 2.5 and y equals 5. So this point is 2.5 and 5. If I plug that into my equation and I say 2 times 2.5, because that's my x, plus 5, does that equal 10? And it does. 2 times 2.5 is 5. 5 plus 5 is 10. So anywhere on this red line that we just drew is an answer to the equation. Okay. So that's why graphs are really important in algebra, because there's multiple answers, right? All right, who would like to see another example? Or you guys want to try it and then come with questions on Monday? All right. So one more example, or are you guys ready to go? Try it. Okay. So, are you good, Sophia? All right. You guys try it, and then if you have questions, we'll go over it some more on Monday, okay? All right. Have a good weekend, guys. Thanks. Bye. Uh, bye.